Hi friends, welcome to Civil Architecture Tutorials channel. Today the subject is regarding pretensioning and post-tensioning of concrete. So in olden days we know the concrete, when the concrete has been invented, we have only the PCC, that is plain cement concrete. We are not using any steel rod in between the concrete to make it more stronger. At that time it was not known. So the problem was that when we are making longer spans of the building, it is not possible with this thing. If it is possible, then we have to increase the depth and width of the beam. Means if the for a pillar it is okay for a pillar, because the main property of concrete is to take compression. Concrete will take as much as compression, but it will take less tension. So as a pillar there is no issue, but when the pillar turns like this and changes to a beam, longer span is not that much possible, because if you, like I said just before, you have to increase the depth and width of the beam, but that is also not practicable. So in that case the engineers added some steel. Like, as you know, when there is a beam like this structure, the load acts upon from the top of the beam, and it will bulk like this. When it acts, it will go like this. There will be a bulking, bending moment will be there. So on the top there will be compression, and the bottom there will be tension. Engineers add some steel member which is better in taking tension. They found out that that kind of combination of concrete as well as steel is good when comparing to a beam structure which doesn't have any steel structure. So in that area, two kinds of forces are taking, that is compression force is taking and tension force is also taking. They are using it for beams, for large structures like maybe a very big building or a bridges. Later again, the problem is that when we add the steel into a concrete structure, it is called reinforced cement concrete, RCC. So before it was called PCC, where there is no steel, it is called plain cement concrete. And then we found out RCC, reinforced cement concrete, where the steel also comes into as a part of the total structure. Again, the problem is that for suppose as an example, if you take the example of a bridge where long span of structure is possible, and we cannot decrease the span, but the problem is that if you are going for the reinforced RCC structure too, it will take up to a certain limit, it is okay. After that span, then the same thing happens, the size of the beam, size of the slab, everything will increase. The engineers think a lot about how to solve this problem, and they found out that when the same thing, when we are applying the force on the top, we need to reduce the size of the slab. How it can be achieved? That is again the same diagram we will see. They are applying the load on here, and again, as I said before, compression is on top and tension is at bottom. But now they found out that they have to add more structural members to the tension area. Okay, but the thing is that they need to reduce the size of the slab. They found out that increase the number of structural members there, and also give tension. You have to give tension to this steel member and then place it. Instead of applying a load from there, we have to apply tension before casting or after casting, it doesn't matter, but we have to give more tension to the steel. We can decrease the size of the slab. That is the main point there. So this type of concrete is called pre-stressed concrete. That is, we are stressing that tensile area prior to applying the load. So what is called pre-stressed concrete is this thing, and it has been done in two ways, that is pretensioning and post-tensioning. Pretensed concrete and post-tensed concrete. So pretensed concrete is the concrete in which that steel member is called strands or tendons in it. We are pretensioned these structural members, that strands first, and then only the casting has been done, then only we are applying the concrete. And this is mainly done in factories, and it is done for small length, or means span, if the span is very small and if it is transportable, and if the crane is also available, then we are going for pretensioning. But post tensioning is done in the case where the strands will be in sheathing. That means the strands there will be strands, and also it will be in a duct-like thing which is called sheathing. And first this structure has been done, and then the concrete is applied. Let the concrete take some setting time. As it reaches some strength, then these strands will be tensioned at both ends with machines to the desirable tensile strength. They will stress it, and after attaining the desirable tensile strength, then they will close that strands on both sides. So that is called post tensioning. So in both these two, the strands has been tensioned to the certain desirable length, so that we can decrease the size of the slab. Again, we will describe the differences between pretensioned and post-tensioning concrete, which comes in prestressed concrete. Okay, prestressed concrete is divided into pretensioned and post-tension concrete. So, as I said, strands are tensioned before concreting, and in pretensioned and in post-tensioning, strands are enclosed in a duct and then casting after concrete attains a desirable strength. And the second one is this pretensioning is done in factories, but the post-tensioning is done in factories as well as inside. Both are possible. And the third one is the size of the section is limited to a small span, because it should be transportable and crane should be available in pretension. While in post-tensioning, the size doesn't matter. It is actually used for the long span. We are using only post-tensioning. One is when the structure is small and easy to transport, this method is available. When the structure is very big, post-tensioning we are using. And the durability part, pretensioning is more durable when compared to post-tensioning, because post-tensioning the durability depends upon the ends of the two strands where it has been anchored. As time passes, that tension will be lesser and lesser, and the durability part also will be less in post-tension. This one is cheaper is pretension is comparatively cheaper when compared to post-tensioning, because in post-tensioning we are using a sheathing. It's a duct-like thing in through which the strands are passing, because we have to do the tensioning only after concreting. So that part is more expensive than pretension, because there is an additional material called sheathing is there. I hope you understand tensioning and post-tensioning and prestressed concrete, PCC and RCC. So we will meet in another video with new subject. Till then, goodbye. Please subscribe, share and like my channel. Thank you very much.